Hello everyone. Today I'm going to start with the subject, with the topic Introduction to Computer Network. The subject name is Computer Networks. Okay, in this video I'm going to cover up the topic such as definition, what exactly the computer network is, application, where it is applicable, where it is used, fundamental characteristics of data communication, component used in data communication, then comes the physical topology, then last but not the least, categories of network. Okay, so definition. First we'll see what is computer network. Before that, going to computer network, we must understand what exactly the network is. So network is nothing but when two or more than two persons are connected for the purpose of communication. In short, if I have to say, the group of interconnected things forms a network. Okay, example of like uh, oldest example of network is nothing but water supply system. Okay, next moving to the definition of computer network: a collection of computer and other devices that are connected by the communication channel for sharing information and resources called computer network. So computer network is nothing but it is a set of computer connected together for the purpose of sharing some resources. Okay, those resources can be internet, printer, or a file server. So here they are saying computer network is also as an information network. The most popular information network is nothing but internet, which is used everywhere nowadays, right? It is most essential thing. Next, application. So there are several application area where the computer network will be used. First one is communication. So it allows user to communicate with each other by sending files to another user. Suppose you want to send one document with the help of computer network. You can easily send it through some like email, right? Mail, electronic mail, or WhatsApp, or any other communication medium. Okay. If in case computer network is not there, how you have to transfer that file? You have to load that data in a pen drive, then that or any other storage medium, okay, devices, then you have to put it in another device, or you have to copy. Like this you have to send the data to the other device. But with the help of computer network, you can easily send receive data at any time. You can transfer data from one location to the another, no matter where the location is, no matter what the time is. You can send at any point of time and it will reach the destination immediately, right? You can easily send the, in short if I have to say, yes, you can easily send the data with the help of, you can easily communicate with one another with the help of computer networks. Not only data, any information if you want to transmit. Okay, next we have is sharing resources. Resource sharing, it allows user to access peripheral device like printer, scanner, etc. Peripheral device, you know, right? What exactly the peripheral? These are nothing but input output devices. Okay, if you are having a printer and you have a different system or computer, then with the help of network you can use one printer with all the other system connected to it. Okay, if computer network is there, if it is connected through a network, okay, sorry, a computer network, then one printer can be used by all the system connected to the to that printer. Anyone can give any information for printing purpose in the same printer. Okay, otherwise without computer you need to have a individual printer to the all the devices. Okay, so resource sharing saves money, is it not? So next is sharing software. Software is nothing but application, you know, right? Some applications, so this allow all the users to share the softwares or application. Resource sharing software, sharing software means what? It allows the user to share some software or say, share some application. Like suppose you are having an application and you have many network users. Okay, this application sharing allows you to share application among all the users, which save the disk space. Okay, because you need to install software in only one system, not all the other system. So and all the connected system can use this software. Okay, as you are using in your labs, like one what is that software will be installed in the server system or the system, one system, and all the other system can use it simultaneously. So next one is last one is data sharing. So what exactly the data sharing is? In multi-user environment, you may be keeping same database, okay, same device. We can have a multiple computer using same or common database. Okay, suppose you are accessing data from Google. Okay, this must be stored on database server, right? Google database server. So this database server is accessible to everyone. It is not limited to some people, right? Only you can use, I cannot use. It is not like that. Everyone can be using that database. Okay, so with the help of google.com or something such as YouTube or any other this one. Okay, so anyone can access the data from database with the help of computer network. Understood? So next is same thing, okay, which I have already explained. Communication using for the network. Different people can communicate with each other all over the world. People can communicate at very low cost. Email, chatting, telephone, SMS service, etc. As I said, you can send mail, SMS, any kind. Data is nothing but which has value or set of value is called data, right? Any kind of information you can transmit within the fraction of seconds. Sharing resources in a computer, and resources such as printer, scanner, fax machine can be shared among different users. As I said, in a network, you can all the system can share a single printer, okay, or a single any peripheral device. So sharing software in a computer network, usually application, program, and other software are stored on a central computer. User connected to the network can access this software. As I said, one system, like in one system, central system, all the softwares will be stored, so it will save the disk space as well. Okay, in only one system we need to save, and all the other system which is connected can access those softwares or applications. Next, last but not the least, as I said, data sharing in a network environment. Any authorized user can access the data stored on the other computer on the network. For example, internet. So this is the internet is the best example for this sharing resources. So next, moving to the next topic, that is data communication. It is nothing but exchange of data between two devices via some form of transmission medium. Data communication, communicating data. Okay, so here what we are going to exchange some kind of data information between two devices via some form of transmission medium. There should be a transmission medium such as wire, cable, or it can be wirelessly as well. Okay, so for data communication to occur, communicating device must be part of communicating system made up of combination of hardware and software. So there should be hardware equipment as well as program. Okay, hopefully you are understanding these concepts. Okay, next is the effectiveness of data communication system depends on four fundamental characteristics. So which are these? First one is delivery. Delivery is nothing but if you want to send data from system A to B, then data must be delivered from A to B, and it should not go to any other system like C. Okay, if there are three systems A, B, C, okay, you want to send from A to B, so it should go from A to the B. The system must deliver data to the correct destination. Data must be received by the internet device and used by only that device itself. Okay, any intermediated device or any other device must not access that data. Okay, this is the first and the foremost characteristics of fundamental characteristics of effective data communication system. Then is accuracy. The system must deliver the data accurately. Okay, so data, while transmitting the data should not be altered. I am sending, okay, data like such as hi, how are you. Okay, it should not something else should not reach to the destination. Whatever exactly I have typed, the same thing should be delivered to the receiver. Okay, next, third one is timeliness. The system must deliver data in the timely manner. Okay, data delivered late are useless, as you know. If suppose I want to send one information, meeting will start at 10 p.m. 10 a.m. So it should reach to you before 10 a.m. Okay, if the data which I have sent, message I have sent, it is reaching you after 10 a.m., then it is useless, right? So in case of video and audio timely delivery means delivering the data on as they are produced in the same order they are produced, okay, without delay. So same order in the same how it is produced, likewise only data must be delivered to the destination. Okay, last one is jitter. Jitter refer to the variation in the packet arrival time. Okay, it is the uneven delay in the delivery of audio or video packets. Okay, example, video packets are sent every 30 milliseconds. Okay, if some arrives with 30 millisecond delay and other arrives with 40 millisecond delay, the uneven quality in video is the result. So it should be enough like same. Now what is that? Equal time delay. Okay, if one packet is delivering in 5 millisecond, then all the other packets should deliver in the same delay. Otherwise this video will be with low quality or like mismatch of voice and video. Okay, you have observed while watching some TV shows or from YouTube, when there will be internet will be slow or some because of some problem, there will be there will be delay in audio and video. The lip movement will not be matched, so you won't feel like watching it. The quality will be reduced and it remains useless. Okay, then okay, next is component of data communication. So this is the diagram which all components are used in data communication. The first thing is sender. Okay, sender is nothing but the one who is going to deliver the data. Okay, now if I want to send, I am A, system A, and I want to send the data to system B. I am the sender. I am going to initiate the data. Okay, I am going to send the data to the receiver. Okay, receiver is one, the device or a node which is going to receive the data. Okay, sender is the device, node, or it can be anything, system, computer, workstation, anything. Sender is something which is going to initiate the data, sending the data, and receiver who is going to receive the data, the device which is going to receive the data. Then we have here something called as transmission medium. You can see here, it can be anything, coaxial cable. There are different kind of transmission medium. It can be wired or wireless. Okay, coaxial cable, twisted pair cable, these are some transmission medium through which the data will travel from sender to the receiver. Understanding? Then we have message. Message is nothing but the information which we are going to transmit. If I'm going to say a packet, send a packet called hi, it is a message. Okay, I'm sending one message. Sender A is sending message to sender B, and the message is what? Hi. Okay, this is what message is. Okay, information. Then we have here, you can say protocols, right? You can see here protocols. Protocol is nothing but it is a set of rules. Okay, so there must be rules between sender and the receiver. Okay, without protocol we cannot, two system cannot be communicated. Okay, so here, see here, the message is the information to be communicated. Popular form of information include text, numbers, pictures, audio and video. This is nothing but message. Sender, the sender is a device that sends the data message. It can be computer, workstation, telephone, handset, video camera and so on. It can be anything. Then we have receiver. The receiver is the device that receives the data message. It can be computer, workstation, same as sender. Okay, it can be anything. Then we have transmission medium. Transmission medium is the physical path by which the message travels from sender to receiver. Example of transmission medium include twisted pair cable, coaxial cable, fiber optics cable, or radio waves. Okay, then last but not least, we have protocol. The protocol is a set of rules that governs the data communication. It represents the agreement between the communicating devices. Without protocol, two devices may be connected but cannot be communicated. Clear? Next, moving to the next topic, physical topology. Okay, so topology is nothing but this is the way in which the network is physically laid out. Okay, or it is the way in which the network is physically connected. All the link or devices are connected. So what they are saying is two or more devices connect to a link. Two or more links form a topology. So two or more links form a topology. So we should understand what link is. Link is nothing but when two devices, two nodes, two systems are connected to each other, this form the link. So many links will be connected in the network. The way in which they are connected is called as topology. Okay, so basically the Definition of topology is: the topology of network is a geometric representation of relationship of all the links and linking devices, okay, to one another. So linking device is nothing but nodes, as I said. Okay, there are basically four types of topology. One is called mesh, star, bus, and ring. So we'll see this one by one. First we'll see what is mesh topology. So mesh topology is nothing but every device has a dedicated point-to-point link to every other device. In mesh topology, every device must have a dedicated point-to-point link. All the devices in the network must be connected point to point. A must be connected to B, B must be connected to C, C must be connected to D, likewise D must be connected to A, C must be connected to A. Like this, every device in the network must be connected to one another. Okay, so the term dedicated means the link carries traffic only between the two devices connect. So the two devices which are connected, their only traffic data can flow. Okay, if A wants to send data to C, there must be a dedicated link between them. A cannot send it through B and B to C. A must have a dedicated link to C. Okay, so to find the number of physical link in a fully connected mesh network with n nodes, we first consider that each node must be connected to every other node. Suppose, take an example, n. Okay, node 1 2 3, so there are n nodes. Okay, so we need n into n minus 1 physical links. What they are saying, if you want to find the number of physical links in a connected mesh network, what we must consider first, main thing is all the devices should be connected. Okay, so n into n minus 1 in a half duplex mode. Half duplex means one way traffic. Okay, so in a half duplex mode, n into n minus 1. For example, there are 5 nodes. Okay, so how will find there is like about the physical links, how many physical links are there? So we can find 5 into 5 minus 1 is 4. 5 into 4 is 20. Okay, in a half duplex mode, there should be 20 dedicated links. Okay, in other words, we can say that mesh topology, we need n into n minus 1 divided by 2 in full duplex mode. Full duplex mode means what? Only one link can carry traffic to or from a node. Okay, so in case of full duplex mode, we need n into n minus 1 by 2. So 20 by 2 is what? 10. So we need 10 dedicated links in a full duplex mesh topology. So this is the diagram. How, see here, this is station 1 connected to station 2, 3, 4, 5. Likewise, station 2 is connected to 1, 3, 4, 5. Station 3 is connected to 1, 2, 4, 5. Likewise, all the devices are connected. So every connection or every topology everything have some advantages and disadvantages, right? So first we'll see what are the advantages. The use of dedicated link guarantees that each connection can carry its own data load, thus eliminating the traffic problem that can occur when link must be shared by multiple devices. When a link is shared by multiple devices, obviously there will be a traffic problem. Okay, so this mesh topology eliminates that traffic problem because there is a dedicated link. The link must does not need to carry the data of any other device. It is going to carry the data of the device which devices are connected. Okay, so mesh topology is robust. Robust means what? Failure of one link will not stop overall network. Okay, a link must be corrected. Okay, so it will not stop the working of entire system. Okay, there is an advantage of privacy and security. So every message travel along a dedicated line, only the internet recipient see it. So if I'm sending message to B, I am A and sending message to B, only B can see it. C, D, E cannot see it. Okay, any other devices cannot read that information because it is dedicated link. Next is disadvantages. Disadvantages because every device must be connected to every other device. Installation and connection are difficult. So installation is difficult. So second is it requires much space to accommodate. I have given only example of 5 nodes. Okay, if there are more than 5 nodes, then we the installation is difficult. The cabling is, it will be meshy, it will be too much. Okay, the hardware required to connect each link can be prohibitively expensive. So hardware cost is more, because they'll, if how many nodes will be there, those many connected links, those many links must be there. So hardware is, so it will be expensive. Moving to the next topic, star topology. In star topology, each device has a dedicated point-to-point link only to the central controller, usually called as hub. Here we have something called as hub. Okay, in case of mesh topology, we had a dedicated link, right? Here also we have a dedicated link, but not to every other device, but to the central controller. Understanding what I'm saying? So every device will be having a dedicated link to the central controller. That central controller is nothing but a hub. Devices are not directly linked to one another. Unlike a mesh topology, a star topology does not allow direct traffic between the devices. So the controller acts as an exchange. If one device wants to send data to another, it sends the data to the controller, which then relay on the data to the other connected device. So if A wants to send the data to C, so A must send its data to the controller central hub, then central hub is going to transmit that data to the C. Clear? So next one is, this is a diagram how the topology, how the stations are connected. Next, advantage in star topology is less expensive than the mesh topology. Okay, other advantage include robustness. If one link fails, only that link will be affected, all the other links remains active. Okay, but there is a huge disadvantage. Okay, what is that? One big disadvantage of star topology is that dependency on the of the whole topology on a single point hub. Okay, if the hub goes down, the whole system is dead. Okay, if hub is not working, then all the system connected cannot work, because every data will be going to hub, and hub is going to transmit the data to another device. If the central controller is failed to work, then whole system will stop working. Next we have bus topology. So now these two topology which I have studied, it is a dedicated point to point link, but here bus topology is a multi-point link. Okay, so here, see here, one long cable acts as a backbone to link all the devices in the network. This is the cable which is going to act as a backbone. All the devices are connected to this cable. Nodes are connected to the bus cable by drop lines and taps. These are the drop lines and taps. With the help of this, the nodes are connected to the cable. Okay, a drop line is a connection running between the device and the main cable. So this is the device and this is the main cable. So drop line is nothing but it is what connection running between the device and the main cable. So advantage of bus topology is, advantage of bus topology include ease of installation. It is very easy to install. Okay, redundancy is eliminated, but disadvantage is reconnection is very difficult. Fault isolation, we can't understand where the fault is. Okay, fault or break in the bus cable stops all the transmission. Clear? Next one is hybrid topology. Hybrid topology is nothing but it is a combination of different topology. For example, here in this hub comes in which topology? Star topology. And these all see here, all the stations are connected through cable, right? So this is what taps. All the stations are connected through drop line and tap. So this is what bus topology. So the bus topology and star topology are going to form one topology, that is called as hybrid topology. Two or more topologies will be used in a connection is called as hybrid topology. Last topic is categories of network. So we have three categories of network: LAN, WAN and MAN. First one is LAN. LAN is nothing but local area network. It is usually owned and linked by the device in a single office, building or campus, like in our college. Okay, LAN size is limited to few kilometers. LANs are designed to allow resources to be shared between PC and workstation. Okay, resources may be hardware or software or any data. So hardware means printer, key, or scanner, etc. And software, any application program like your MS Office or any like any program, application program. Okay, this is nothing but LAN. Next is WAN. WAN is nothing but it provides a long distance transmission, okay, of the data, image, or data is nothing but it can be image, audio, video, or any file, any kind of information over the large geographical area. Okay, they may comprise a country, continent, or even a whole world. WAN can be connected even it is a wide area network. Whole world can be connected through this network. Then last one is MAN, Metropolitan Area Network. So it is sized between LAN and WAN. Okay, it is not limited such as LAN, and it is not like WAN, like whole country cannot be connected. So it is between them. So like it can be inside a city or a town. Okay, it is designed for the customer who needs a high speed connectivity normally to the internet. Okay, this is what LAN, MAN and WAN. Thank you.